Introduction to Complex Numbers 1. The search for solutions to equations of the form x squared equals negative a squared led to the development of the complex numbers, specifically the number I equals the square root of negative 1. Recall the quadratic formula for finding roots of the equation ax squared plus bx plus c equals 0. What is it? Well, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. What is the condition that a, b, and c gives complex, that is, non-real roots? If b squared minus 4ac is less than 0. If you recall, this is called the discriminant. In a previous course, we investigated the numbers for the equation x squared equals 1 as part of our study of polynomials. How many solutions does this equation have? It has n solutions. Find solutions of x to the nth equals 1 when n equals 2. What are they asking here? They're saying x squared equals 1 and find the solutions. Well, if we subtract 1 and factor, we get positive 1 or negative 1. If we then move on to the next one, what about when n equals 4? X to the fourth equals 1. When x to the fourth minus 1 equals 0, we could factor again, x squared plus 1, x squared minus 1, factor it further, and reveal the four answers, plus or minus I, and plus or minus 1. If we continue this pattern, take a look here, and you see we will get 8 answers. 1, 2, 3, 4, 5, 6, 7, 8 answers when we have plus or minus I, plus or minus 1, plus or minus I, plus or minus root I. Let's talk about delta math next. Simplify the expression to a plus bi form of this addition. Well, negative 12 plus 2 is negative 10, and 4i plus negative 2i is plus 2i. So this sum would be negative 10 plus 2i. Be ready to do something like that without a calculator. Subtraction, just remember to distribute that negative sign. Negative 2 plus 5 would be 3. 5i minus 8i is negative 3i. For this next one. Simplify the expression to a plus bi form, negative 2 minus 8i times negative 3 plus 6i. Now, of course, if we have our calculators in the right mode, then we could do this. Negative 2 minus 8i times negative 3 plus 6i enter 54 plus 12i. But we know that you're going to have to do some of this by hand as well. So be ready to do this with these exact steps without a calculator when called to. So with or without a calculator, you should be good to go. Negative 2 times negative 3 is 6. Negative 2 times 6i, negative 12i. Negative 8i times negative 3 is positive 24i. Negative 8i times 6i is negative 48i squared. We replace I squared with negative 1 and then combine those real parts, and that's how we got to our final answer. The next type of problem is to do complex numbers to powers. So let's again use our calculators to start with here. 3 plus I to the fourth, 28 plus 96i. And again, here is how we would do this without a calculator to get to the same answer. I would probably use a box method. I would square it and square it again, which is essentially what they do. It doesn't necessarily need to look all of these same steps, but you do get 28 plus 96i. In our next problem, we're going to divide, and we're going to need to use the complex conjugate. When we do it by hand in the calculator, either use parentheses or make it a fraction, and it'll do that for us. And that gave us 1 minus I. The complex conjugate is, instead of 4 plus 3i, we multiply by 4 minus 3i, which this term is just 1. Multiply out the top, multiply out the bottom, combine, make the I squares equal to -1, and just work your way down, and you get that same answer, 1 minus I. So back to complex 1. Let's revisit graphing in the complex plane. We're going to call the x-axis the real axis and the y-axis the imaginary axis. So if we have some point a, b, the complex number z, a plus bi will be located there. And so let's see what that would look like for this first one. -8 plus 9i. In GeoGebra, I'm just going to type that in. -8 plus 9i. There it is. Notice that it changes it to z, since it's a complex number here. It's in quadrant 2. And you just have to go to the left 8 and up 9. So pretty straightforward here. And that's our introduction to complex numbers. We will continue working with this in class.